let's see the program that does this. Here's the program that does this. Have a number, and you check if it's less than 0, and if so, you just stop the program. You stop the function. You basically return. Okay? You could have waited. You could have made if count is greater than or equal to 0, do this, and then return would happen down here. But it doesn't really matter. In this case, we're done with the function if we hit the base case. Then we print out the number, and then we call countdown with 1 less than what we started with. Yeah.
This particular case, is it better to use recursion or something?
In this case, it's better to use a simple loop. Good question.
As far as like data-wise.
Yeah, you would totally never do it this way. Like if you were really doing counting down, you would not do it. You'd just use a loop. But we're showing you this so that you understand how it works. We got to build up from baby steps, right? Okay. All right. So does everybody agree that this works? It's going to call countdown with 3. And then it's not going to be less than 0. It's going to print 3. Then it's going to call countdown with 2. And you're going to start back at the top, and et cetera, et cetera. We good with that? All right. Let's talk about counting up. Yeah, sorry, Bianca.
Just a quick question.
Yeah.
If you had a line after countdown, count minus 1, would
Yeah.
it ever reach that line?
It would. When would it reach it? Well, that's a very good question. We have time to do this. I like that question so much, I'm going to stop, and we're going to do that question right now. Do I have countdown? Hang on, not on the server, I don't. OK. Do I have countdown? Yes, we do. I'm going to make a copy of it. Countdown to .cpp to countdown Bianca.cpp, because it's such a good question. OK. And I'm going to look at this, and we're going to modify it. And how would we tell what happens after here? How would I debug something to see if it ever got there? See out. Bianca was here at, and then we'll print out count. Right? OK. So that's what's going to happen now. We're going to do this. And before, here, I'll show you what happens with both of them. We're going to try this one. Oops. OK. We're going to try this one first. Count down goes from 5 to 0. So it's going to count down. It's just going to go like that. OK. So let's make the other one. Clang, plus, plus, whoa, extra. Let's see. It's going to be countdown, Bianca.cv dash O, countdown, Bianca. OK. All right. We're going to do that, and then we're going to run it. Now, I should ask you, I guess if I was kind of mean, I would ask you, what is going to print here? And you would walk through this one line at a time. You'd go, this is going to print. But before we do that, let's just see if this confuses you. Countdown Bianca. Now, let's see what happened. So let's remember what happened here before we go look at the program. It said 5, 4, 3, 2, 1, 0. And then it says Bianca was here 0. Bianca was here at 1. Bianca was here at 2, 3, 4, 5. And then the program ended. Let me write this down. All right. All right. Let's start at the first time we call this. Count. Let's do it with 3, not 5, because that's too many things. OK, let's do 3. OK. We start out, we've called it with count is 3. OK. And we've called countdown 3. OK. What does countdown 3 immediately do? Checks to see if it's less than 0, which it's not. And then it prints out what? 3. OK. So it prints out 3. All right. And then what does it call? Itself, I'm going to abbreviate CD. CD, and what is it going to call it with? 2. OK. And then 2 does what? Checks to see if it's less than 0, and then it's not, so it prints out 2, and then calls countdown 1. Okay, and then same thing, it's not less than 0, so it prints 1. Countdown 1 calls countdown 0. It's not less than 0, so it prints out 0. Countdown 0 calls countdown what? -1. Countdown -1. And countdown -1 does what? It says it is less than 0, so we return. When you return from a function, where do you go? Where do you go? No, you don't go to main. You go to the previous thing that called you. Who called countdown -1? Countdown 0. Countdown 0 was here and said countdown -1, and then what does it immediately print? It prints Bianca was here 0. And then that function ends because it gets to the end of the function. And then where does it go? Who called countdown 0? Countdown 1 called countdown 0 from inside countdown 1, and then that returned. Countdown 1 just returned, or sorry, countdown 0 just returned. So now we're back in countdown with a count of 1, and so now we print out Bianca was here at 1. And then that function ends. But who called countdown 1? Countdown 2 did. So countdown 2 called countdown 1, and then countdown 1 ended, and countdown 2 ends up here and then prints out. Do you see how that works now? This is why it's such a good question, because this shows you that as you're inside a function, you have to return from every time you called down there. Every one returns to the previous function that called it. So if you're calling it in this loop, you've got lots of calls. Countdown 3 calls countdown 2, calls countdown 1, calls countdown 0, calls countdown -1. -1 ends back to countdown 0, which does the rest of its stuff. Back to countdown 1 does the rest of its stuff. Back to countdown 2, back to countdown 3. Question?
Oh, I just wondered why you have to return like 10 times.
You do have to return n times, but that's happening here. Notice, that's good. You are returning n times. That's why we printed out all of the returns. Right? Bianca 0 was returning, then 1 was returning, then 2 was returning, then 3 was returning, 4 was returning, and 5 was returning. Yeah, very good. Sean?
What if you call countdown after the countdown statement? Like if you call countdown n-1 and then under that one instead of Bianca was here.
Oh yeah, you could end up getting really ugly things. Try it. See if it ends ever. I'm not sure. I'm not sure off the top of my head, but you'd have to see. Okay. Yeah.
If you wanted to see out that exact thing, you wouldn't do it that way, right? So you're very complicated when doing it.
Probably not. But again, same idea. We're trying to get baby steps here. But that was a really good question and showed you how this stuff actually works. And if that was over your head, great. Go change it to that and run it yourself. Because you should be able to figure out what's happening in here. And it's all about, wait a minute, a function has to return to who called it. And this is the problem. This is why you get Stack Overflows. Because 179,000 times, this one calls this one, calls this one, calls this one. All those functions haven't returned at all. They're just waiting for the one way at the end to return back down the stack. Okay? All right, last thing for today. Yeah, question? Evelyn? No. Okay, last thing for today. What about counting up? Counting down is easy. You're always going towards one number. Right? If you know you're going towards one number and you're counting down, 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 you're always going to stop at that number. If you want to count up, there's nowhere to stop. You can't know where to stop, right? It's not like you have a 0 to stop at. If you're counting down, everybody's going to funnel into 0. If you're counting up the way we've done it, there's no extra information to be passed to say that you're counting up. You can do it this way. You could have another variable here that keeps the maximum that you're going to. Let's see if this works. Count up to 5. or sorry, count up from 0 to 5. If count is max plus 1, because we're going to want to actually have the 5, return. Otherwise, print out count and then count up from 1 to max, and then count up from 2 to max, and then count up from 3 to max. We're just passing the maximum along. Not a terrible way to do this. There's an easier way, which is actually kind of tricky. Would this work, by the way, if I went up here and changed all the downs to ups? Would this work? Void countdown int count. If count is less than 0, wouldn't make less than 0. What would you put there instead? You can't put greater than whatever. You can't do it that way. Zach, do you have a comment? No. Comment? OK. Let's see. We can't do it that way. But you can do something very, very clever. And this goes back to exactly what Bianca's question was earlier, actually. OK? What if we did this? What have I changed here? If count is less than 0, return. That's the same. Count up, count minus 1. What did we do before? We printed before. Now we're going to print afterwards. This is exactly the same idea as before. Exactly the same idea as before. In fact, it's almost exactly the same as this, except now we're not printing things quite yet. Count down or count up 3. Call count up 3. Okay? All right. Count up 3 says if it's less than 0, return. It's not. Immediately call count up count minus 1. Has it printed anything yet? So we get countdown 3 calling countdown 2. Countdown 2 says, am I less than 0? No. Is count less than 0? No. So if count's not less than 0, we're going to immediately call count up 1. And then count up 0. And then count up negative 1. But when count up negative 1 says, oh, OK, count is less than 0, it returns to where? Who called count up negative 1? Count up 0 here, then count up 0 returns and ends up here and prints out 0. And the same thing happens because that ends, and then count up 1 called count up 0. Count up 1 ends up right there. It ends up printing 1. That returns who called count up 1, count up 2 called count up 1, and then 2 prints because it just returned, count up 1 returned. Now we're still when count is 2. Count up 2 returns to count up 3, prints 3. Who called count up 3? Main did. Nothing after that. We don't print anything else out. It's exactly the same question as yours. It's exactly the same idea as yours. OK. I know this recursion stuff is like, woo, swimming around in your brain. It's OK. We're going to start back on recursion on Thursday. OK? See you guys in lab.